Hey there, welcome back. So today the video is not going to be that long. So let's try to make it as as informative as possible, or should I say, like learn as much as possible in a shorter amount of time. So let's get started directly. So what did we do yesterday? So CD desktop RLF and then dot allocator.c. Yeah. So yeah, we were over here. So I learned about something which is pointer to a pointer. Yep, that's what we have to do. We have to just. Uh, so I'll show you what I was thinking. So another thing that I'm thinking of is a design change. I know, but it seems like a good design change, but I'm not sure. Okay. So let's say this is block 1, block 2 and block 3. Uh, Initially this is what the block looks like. So size, void pointer and then size again. So what is pointer to a pointer? So this is what we are going to do. Yep, that's all. And I was like hesitant to like in the previous video I saw that and I was like, okay, I don't understand that, but now I do. Like not a lot, but basic idea. But we'll still be learning about it. Uh, I just have a general idea, like okay, it's a pointer to a pointer. I've seen like a diagram of it, and it sounded okay. So let's say this pointer has an address of 123. Okay, so in this pointer, so in this place, I have to store the address of this pointer, right? So that's what I will store. Here we have stored 123, but the actual address of this pointer, the memory address of this pointer, is 4, 5, and 6. And if I will store here 4, 5, and 6, but the actual address is 7, 8, 9. So how do we access this value when we reach? Let's say this is what free is. Okay. How do we access this value? That's what we wanted. Well, we can access that since this is a void pointer. So when we write void pointer, let's say void pointer this, so this line, what this line does is it converts this into character array. This is what the address is, and then it moves by size t size. So here, and then we take this as void pointer, but void pointer will give us this value 789, but we want this value, so we say it like it's a pointer to a pointer. So now we have 456. That's it. Yep, that's what I learned. Okay, so I'll show you an example of what it looks like, of like what it is. Let me just do 1199 1199. Yep. There was a cool diagram that I saw. Like it's not cool. Yeah. This one. Yeah. So this is what I saw. So pointer to a pointer. So num10 has an actual address of 130. Uh, and okay. Also a shout out to Code for Win. This is not my image. It belongs to them. But thank you. So that's what we are going to do. When we write void pointer to a, let's say we are over here. When we write void pointer to a pointer, what we get is the value inside it. So yeah, that's what we are going to do. So void pointer to pointer. But still, to demonstrate this, like I'm not sure whether this is the change. Like I'm not 100% sure, but that's what I think. So let's demonstrate it. Like not demonstrate, but let's test it. So nvim.c. We'll just remove it altogether. It's loaded. No, not remove it. But we'll comment this out. Yeah, and we'll also comment this out. Right? Yeah, let's do it. So, okay. So, if we are over here, let's test it. So, what are we going to do? Yep. So initially, so let's say LMN. Let's take AB. Let's take ABCD. So void pointer A is equal to mem sbrk increment. Let's change the we can say the value. So like block. Yeah, that sounds great. Block. So we get a void pointer to the address of the block. It's it may be currently so I'll do again. So void b, or should I just do this? Yeah. Find a, replace with b. Find a, replace with c. Yeah. So let's say I want to store the address of b inside a and the address of c inside b. So let's try that. So initially, let's print that thing. So pointer a is here. So a, find a, replace with b, replace with c, find a, replace with b, replace with c. So if you run this, blank temp.c and an a dot out. So we have that over here. We have addresses of the pointer. You can say what it's pointing to. So nvim temp.c. So it does p return. So does %p show the address of pointer or the content of pointer? It should be showing the address of pointer, right? So does %p print the address of a variable as a pointer, or does it print what it points to? So int x, I've read a lot of the. As the multiple posts on the site, and I even read the article, but it did not explain it adequately. Int x equal to 10, void pointer x and x does the. So void stop. So p stores the address of x. I'm trying to get the address of x through p. Okay, for some context, I'm iterating over the stack, looking for pointers pointing into a linked list. Okay, it prints to the contents of a variable p, which happens to be the address of x. Okay, yeah. So this is the. So if I do this, so printf pointer, or should I say address of a, address of a, what does this give me? This is the actual address, right? Replace with b, replace with c, find a, replace with b, replace with c. So we have this address. It's separated by 8 bytes. So 68 70, not 88, because there must be like some things that are different. But okay, so EA 70, 78, whatever, whatever. Okay, okay, fine, 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 fine. So let's say, so pointer, if we do this, what does it show? The statement prints the address of x because this is wait, what? The statement prints the address of x because this is a value stored in p. The statement prints the address of x because this is the value stored in p. Of course, p does not need to be valid or to point to anything in particular. In general, functions cannot take an address of variable without you explicitly operating the address of with the AND operator. So if you wanted to print address of p, you would have to do it something like this. Yeah, that's what it did. This shouldn't be anything different, right? It is. I think it's already happening implicitly. Yeah, no change. So this is the address of a pointer. We have to store the address of a pointer to the thing. So why don't we just do like b is equal to and of a, or a is equal to and of b. So what does this do then? I should say before, so printf before and then after. Okay, so BCE is 70. '78, 70, 68, 78, 70, 68, 70. Yeah, so the pointer A now has contents of the address of what you could say, the address of the next block. That's what we are going for, right? I hope that's what we are going for. So what is pointer to pointer? Let's check geeks for geeks. We cannot dereference anything, right? Dereference. What does void pointer? Today when I was reading this code, I saw something like void pointer. So only what does the void pointer mean here for the function name and variable type respectively in the addition when do we need it. A pointer void is a generic pointer type. A void pointer can be converted to any other pointer type without an explicit cast. You can dereference a void pointer. You cannot dereference a void pointer or do pointer arithmetic with it. You must convert it to a pointer to a complete data type first. Void pointer is often used in places where you need to be able to work with different pointers types in the same code. One commonly cited example is the library function qsort. This is the address. The comparison function would look something like this. Okay. So to look at like the pointer to void pointer to a pointer. So no clankers, no clankers. So wait, if I have to create a list, Why don't I just use the address? So I don't get it. Wait. So if I'm doing this sentence, that means I'm printing the contents of A, right? But that pointer is pointing to somewhere. Let's try to dereference it then. So printf let's think of what we want to create, right? So I want to be able to store. So if I have this diagram, so this is not the way to go, I guess. So if I want to store the address of this pointer over here, then I can just do like void pointer 456, not 456, but whatever is present over here is equal to and of A. What is the difference between storing the address of pointer and pointer to a pointer? Let's look at that. Yeah. Between storing address of a pointer inside a pointer and pointer to a pointer in C. Difference between passing pointer to a pointer. Is this it? Difference between passing pointer to a pointer and address of pointer to any function. Okay. What do they mean in this article? Let's just show me the code. So void pointer, int pointer, int b is equal to 2. Pointer is address of b. That's fine. PTR is equal to int pointer malloc size of int. It can be executed instead of this, but nothing changed. Okay. Before the function pointer, after. Yeah, that's fine. That's fine. Nothing much over here. So int pointer, address of a, yeah. The reason why there is no change in the output, we did it. So we created a A, we stored the address of A inside PTR, and then we call the PTR because a copy was created, right? What's the difference though? So pointer is equal to address of B, and here we are saying dereferencing B is equal to B. Yeah, sure. Then we changed like the value. That's fine. But what is this here? Okay, if it is wanted to replace somebody stored in the pointer. Yeah, sure. So int b equal to 2, void pointer, it takes in a pointer to a pointer, and then dereferences pointer 1 to address of b. Okay. So int a is equal to 5, pointer is address of a before the function, new value of the pointer is 5, that's fine. Foo, address of pointer. Yeah, that's what I mean. That's what I literally mean. Okay. Got it. So I have to go like this. So void next block is a pointer to a pointer. So the next block that I found is a pointer, but it points to a pointer. And the value that it has is is the one that I get from this. Should I should I get like the and from over there? Wait. So wait, I had a call. Okay. Um, so what was I saying? So yeah. So let's look at the function again. So free pointer size t is equal to align requested size. We get a multiple of 8, and copy free pointer is free pointer. We create a copy of free pointer so as to not lose it. Then while copy free pointer is not equal to null, we iterate the copy free pointer. So size t block is the address to that thing. So size t block is equal to size t copy free pointer. If size block is greater than or equal to size t size, return copy free pointer. Else void pointer to a pointer. So or else next block. Else the next block that we find. Next block is a pointer to a pointer that we get from pointer to a pointer. Let's try creating a free list. What do you say? Let's create a free list over here. I should have kept the ABCs. So I have ABC. So ABCs block, and then through ABC I'm getting the pointer to. I'm so blank right now. Why is pointers? Why are pointers so confusing? It should be simple. Maybe I haven't studied them like efficiently. Like I haven't studied them at all. You can say, but okay. For a beginner, I guess it's a bit heavy. It's not heavy. It's just confusing. The pointer to a pointer and address. Address is fine. I understand the single pointer stuff. But I should see a demonstration of like the double pointer, so that will be like better for me. So pointer, we given the address of the pointer. So if we given address of a pointer, that means like okay. So this is the address. This is what it points to. Right? Yeah. Address of a pointer. So inside this, when we say char size, let's think about the designing stuff first. So should we move the pointer like forward? So should we keep it size pointer space size, or uh, what is it? Pointer size space size. Let's move it. So from now on, this is the main diagram. Let's move it. I think that this is a good decision. So we are going to be moving this. So now instead of this is what our block will look like. Size. Space. Okay. So this is our new diagram. So let's go ahead. It's not much, we have to just change a few things. Also we are back. We are so back. We are not back yet, but okay. So mode is working, stream is working. Yeah. Okay. So if I get a pointer to get the size, I don't have to do like okay. If I get a copy pointer to a pointer, if I get a pointer then to read the size, I have to go like, let's remove this again. No, not remove it. That's redundant. So size t pointer. What? Why I was doing size pointer? Okay, yeah. So size block must be, so the size pointer that I get is copy free pointer plus pointer size. Okay, and that's what we have over here. So if size block is greater than size plus size t size, then return copy free pointer. If it's not, then else void pointer to a pointer. Next block is equal to the char pointer. So we convert the char pointer. We have to do it. Sorry. Yeah. So why don't I just do this? Yeah. It looks better, right? Yeah. So copy free pointer, char copy free pointer. Why don't I just, sorry. So now I don't have to like do the mental mathematics, right? I don't have to do all of this. I don't have to convert it to char and all. So copy free pointer. So to get the address of the next pointer, so like move it. So free pointer is pointing to the okay. I think I get it a little bit, but let me just think a bit harder. So I will erase this. A clean slate now. So free pointer shows the address of a block So this is what it looks like. So free pointer variable, it is a pointer, so it has its own address. This is its own address, but it has a value of 0x123. So free pointer points to the address 0x123. So if we want to go to that address, sorry, when we do percentage p, we get this value. So percentage, so printf percentage p of free pointer gives us 0x123. Why? Sorry. So to printf a percentage p, a free pointer gives us the address of 123. So now to move to 123, wait. What? Sorry. I have to like shorten the screen, and I should make a shortcut to it so it will be like better. It's okay. What we read about this here. What I know that pointer is saving the first. What I know that pointer is saving the first address, and also all the addresses got the same size. Why we need to know the object size? So void pointer vptr is equal to this. So the vptr. I know this does not work, but why void p is wrong? It just allocates the size of the address. Just void star p. Can dereference avoid without noise stripe, dereferencing void pointers. Wait. So what does percentage p give in C? So the percentage p is a format specifier used by printf and scanf functions in functions to handle the pointer. It allows us to display as well as read the memory address pointed to by a pointer. Pointed to by a pointer. Pointed to by a pointer. So void pointer is a pointer to that address. So when we ask memsbrk, it is giving us a void pointer which points to that memory address. So when we call memsbrk, it allocates a space, let's say 0x 11111, whatever. It returns as a void pointer free. It has that address built in. It has its own address. So xy, so 0x222. So when we run memsbrk, a memory is allocated at this address, and we get a void pointer that points to that address, right? So it already does the thing. Why do we have to do anything different? Wait just a minute. Something related to electives. Okie dokie, okie dokie. Hey there, just a minute. Sorry for like taking your time. You can just skip it. But sorry. Just a minute. Fine. I'll do it later. So yeah. So we are here 1199. Yeah. Let's go. So where was I? Yeah, the percentage p. How to use percentage p in C programming? Okay, so percentage p specifier allows us to print them and manipulate pointers with ease to use this. Okay, examples. So what do you do? Pointer to an address. Okay. So when I do this, copy free pointer gives us the free pointer. So free pointer, let's say free pointer initially points to null. So when I say free pointer, when I do point void copy free pointer, then I get like wait. Okay. Yeah, let's get it working. So, yeah, so, okay, void pointer to a pointer, void pointer pointer. Oops, not nodes. Will this have something? It doesn't have that. So, O of 1, yeah, it doesn't have anything. Pointer to a pointer. Plain old pointers to, yeah, okay. So what's the use of pointer to pointers? I already get the idea of plain pointers to data, plain old pointers to data. All a pointer is a memory address where some data lives. The plain old pointers are generally used to iterate through things like arrays and trees and nodes to access data on the heap. But where are pointers to pointers actually useful, or triple pointers, etc.? The only places I can think of where they are useful are multidimensional arrays and navigating through lists of mallet objects. Are there any other use cases where just a regular pointer? Okay, one example is the very first function. So, okay, this can also be given as, okay, arrays in function parameters decomposed to a pointer to the first element in C. Okay, so you know that a char pointer can be used to represent an array. Okay. Why do you want pointers to anything? Then figure out what you would do if that thing calls itself a pointer. Just this. The only places I can think of where they are useful are multidimensional arrays. Okay, size tree, get line. Didn't get enough like good answer. How do pointers to pointers work in and when might? Okay. How do pointers to pointers work in C? When might you use them? So let's say we are here. What you can see here is that address 63. Yeah, address 63. The string hello starts. So in this case, if this is the only occurrence of hello in memory, then const character const char star c, so char pointer to c is equal to hello, defines c is equal to defines c to be a pointer to the read only string hello, and thus contains the value 63. C must itself be stored somewhere. Yeah, C must itself be stored somewhere, and thus contains the value C must itself be stored somewhere. In the example above at location 58, of course we can not only point to characters but also to other pointers. Example, const char pointer to a pointer, cp is equal to and c. So now cp points to c, that is, it contains the address of c. So now cp points to c, that is, it contains the address of c, which is 58. We can go, okay, we can 58. We can go even further, consider cpp and of cp, so 55. Now cpp stores the address of cp, so it has value 55. Okay. All these pop-ups. So as to why use pointer to pointers, okay. So what I will have is when when I ask for, so let's say free pointer is let's say I ask for memsbrk. Memsbrk gives us a pointer which points to the memory location, and in order to move my pointer to that memory location, that is just simple. So just a minute. I'm going to mute it. Let's continue. So we were stuck over here. So void pointer to pointer next block. Not to this. So let's say let's just write like what we want. So next block, what we want is that when I write copy free pointer, so on the right hand side, what I want is the address. So I want the so what does copy free pointer points to? Copy free pointer points to the address of the next. So next to next. So yeah, I guess that is correct. So copy free pointer is void pointer to pointer. So we tell like so we so we tell it like consider that the copy free pointer is a pointer to a pointer. So we say I'm so confused and so are you guys. Yeah. So initially let's say we are at free pointer this we start iterating. So copy free pointer is free pointer null? Well, it's not. So what is the size block of copy free pointer? So copy free pointer is 0x123. So this is this right. So we are over here. So we must be over here, right? Yeah, we are over here. So size block. So size 3 pointer copy free pointer plus ptr size we get this. You guys are able to see this, right? Yeah. So this line, oh, you guys aren't seeing it. Oh yeah. So when we do the line, so we get this size. So we say that one of our codes is like so if we want to, so what does copy free pointer store? So copy free pointer stores the pointer to the next thing, right? To the next thing. So when we say we want copy free pointer to point to this, so this is so void. So next block should be this, right? So here, next block is I think we have to take the help of. Oh no. Okay, we'll try. We'll keep trying. We'll keep failing, but it's fine. But we are not moving forward. We are just wasting time in something. That's not great way. That's not a great way either, right? Wait, sorry. Wait, so. Does SBRK return a pointer or a address to the memory block? Okay, simple question. I'm going to use a clanker. No, I shouldn't. Okay, what SBRK return very long addresses? SBRK address ascending or descending. When SBRK returns a pointer to an address, what that is the beginning of the heap, are the addresses ascending or descending? For example, if I had 10 bytes heap for address 1 to 10, would SBRK return a pointer to address 10 or 1? On a similar note, heap address tend to go down, but how can I figure out whether the address increase or decrease on my computer? The man page on Mac OS X sees the VRK and SBRK functions are historical curiosities left over from earlier days before the advent of virtual memory management. The current value of the program break is reliably returned by SBRK 0. Okay, void base pointer SBRK 1024. After that, assuming no error, base will contain the starting of address of 1024 byte minimum block of memory. So base is a pointer to the memory address. Base is a pointer to a memory address. The base pointer itself has an address. But I don't necessarily care about the address of the pointer, right? So we create a copy of free pointer. Copy free pointer. Let's just remove this, or not remove this. Let's try to write again. So yeah, so copy free pointer until it's not equal to null, and let's get the value of size t. So size t, size block is equal to well, we have to convert the block, right? So copy free pointer points to it plus ptr size, because we have to move forward by ptr size and then convert it. So size t, size block is equal to size t, yeah, size t so size t actual size is equal to dereferenced. Okay, if actual size is greater than or equal to size plus size t size plus size t size, if it is greater than or equal to size plus 2 times size pointer, then we'll just return copy free pointer, right? So let's say free pointer, this is a copy. If we found out like the if it's not, then what we'll do, we have to move forward, right? If it's not, then we have to check out the next block. So where is the next block? So next block is present at, so the address that we have to move one step forward, right? So copy free, we have to move one block forward to copy free pointer in this context window, and then we have to move to the next context window. So to do that, we can say it's a void pointer, right? So copy free pointer will become, so copy free pointer will now become, what will it become? So what does free pointer have? So what does free pointer have? Free pointer, so this is the context where free pointer has 0x123, which is the address of the next pointer, and it has its own address. So this I want over here for this pointer. So I want to do something, so this moves. Sorry. If I say if I say void pointer, so to get, so I have this already. So if I get so what we are doing initially is that I think I can I think again strong words, but I think I got it. So what we are doing initially is that when we say, so this is what it was present earlier, this was not there. So what we were doing is we were saying that copy free pointer, let's make it char, let's not increase it by size t, come on, so g, let's not do this. So void pointer, so we were doing this mass because now we have changed, so we don't need it now. So this is what we are doing now. So if we say, if we want to get, if we want to move that, so let's say next block is supposed to be the next thing. So next block is equal to, if we see, if we do this directly, then it's just the same thing, right? But if we do this, so void pointer next block, void pointer, so next block is a pointer to a pointer, where we say like the copy free pointer is a pointer to a pointer, and then we dereference it. So copy free pointer is equal to dereference of the next block. So it gives us pointer, right? This must be it. This must be it, right? Ah, am I thinking straight? So else void pointer to a pointer next block is equal to void pointer to pointer copy. So we say like the copy free pointer that we have right now is actually indeed is actually a pointer to a pointer, and then we say next block, then we like dereference it. So copy free pointer will now become the dereferenced next block. So we say consider that copy free pointer is a pointer to a pointer, and then we move it. Or we could have done a simpler thing, which is copy free pointer. No, okay, it's fine. That's good. So I guess this should work. So copy free pointer is now the address. Okay, I'm still not sure, but okay, we'll continue. So okay, if we don't find it still, then we just do then we just return. Will we have to return something, right? So my malloc size that we want. So this is it. We just didn't do anything. We just fixed something. Now that we have done iterate free list, or I'm not sure if we have done it. This looks weird, but it's great. So okay. So here casting the void pointer to size pointer pointer, getting the actual size from the pointer by dereferencing it. Okay, how long is it? 1 hour 15, 1 hour 5 minutes. Yeah, let's just end it. So, yeah, this is like the abrupt ending, but I'll fix this for sure. I'll fix this for sure. So yeah, it's just okay. Also, one more thing. So we'll meet like 2 days later, because I've moved my schedule, and as I said, the Tuesday is also going to be a project day. So 4 days in a week, the videos will be coming out 4 days a week, and yeah, let's go. Uh, it might feel a bit slow because yeah, I'm not using any clankers. So yeah, I'm Anta Bachorne, and I'm an engineer for fun. Bye.